Yes. Good morning and welcome to our introduction in fire safety on RoRo vessels. We have really looked forward to share all the information we have gained the last 4 years in the last fire project. I will shortly introduce to you what we are going through. We have Marvin Damshan, who will talk about drone system. Davut Sanali, who will talk about the new technologies in the fire detection. Vasudev Ramachandra, who will talk about electric fire safety, reefer units. And we have myself, who will talk about the experience we have done in less fire and how we have used it on board our vessels. Alexander Kleiman from DBI, he will talk about electric vehicles, fire safety at sea, and once back in the port. And I think we will go to the next slide. If I can get it to work, there we are. This is all our partners in the Las Fires project. We are 25 partners here, so we work together the last 4 years. We would also like to welcome the people who are streaming today. We might have people on board our vessels who are looking at our introduction and what we have done. So please, welcome to you here, the audience, and people who are streaming today.
Yes, let's see if this microphone works. Hello everyone, my name is Frans Evergreen. I'm the Director of Fire Safe Transport at RISE, and I've also been the coordinator of this project. We would like to introduce a Menti. This is really just to test the tool. So if you've never used it before, it's really easy. Just use your smart device or your computer, and those of you who are streaming, you can do it as well. So you just go to menti.com and you use this code 3192 1637. 3192 1637. And you can go to the next slide. Oh, sorry. Okay, switch screens, yeah. Sorry. And we'll see who is here. So it's really a question of what organizations are here, and also on the streaming to see what organizations you are representing. So it seems like most of us are from operators, system suppliers, academia. It's probably all the colleagues of mine. And we have flag state representation. And it's also nice to see that crew members are also online and watching and here as well. And we have some other. Who is the other here present? Probably somewhere else. Okay, so this is just really to introduce the tool, and we'll use it for more serious questions at the end, after all the presentations. So that was all from me. So I give back the floor to Lena. Thank you very much.
Thank you, Frans. And I would like to introduce Marvin to talk about drones.
Yes. Hello everyone, I'm Marvin Damshan from RISE, and I wanted to tell you a bit about the drone system that we developed within the Lash Fire research project. I'm from a group at RISE that is called Dependable Transport Systems, and we look into safety and cybersecurity issues in multiple domains, and here we looked at the maritime domain, of course. So we built a drone system and prototyped this to fulfill 3 use cases. The main use case was fire patrol, and I will tell you a bit more about it in the next slide. The fire resource management, where if you have an active situation and you want to understand it better, that you can use the drone to get a unique view from the drone's perspective. And then something, a thought that if you have this technology on board, you can also use it for search and rescue missions. But this was not the main use case, but it's something that gained a lot of interest. So our task here was to investigate whether this is technically feasible. If it's feasible, if you're allowed to do it legally, how do the regulations look like? And I will not go into detail in the legal feasibility, but I can tell you that there's work to do, and it would be interesting to work with operators to use this drone in the long term and do a risk assessment. And then the usefulness. So if you have this system technically feasible and legally feasible, so is it actually useful? What do the end users think? So what you can imagine in the fire patrol use case is that you have a drone on the ship, and it lives periodically, flies autonomously around the ship, gathers data, and then if there's something of interest, it will notify the crew, and the crew can investigate it further. And then eventually it will land autonomously again. So this is to identify risks very early. We often get the question of what about weather? So there's rough weather at sea, and so what I like to point at is a company that is called Volocopter, and they actually have a similar design of an aircraft. It's a certified aircraft, and so my response to the question is it's a question of the price. So how much do you want to pay? And this is the resistance is directly coupled to the price that the drone will cost eventually. So for a price range of 10,000 euro, around 10,000 euro, you get a wind resistance of 50 kilometers wind constant plus gusts and 10 millimeters of rain power. Looking at the system, the main sensors that we have is a standard camera and the thermal camera, and these images are then processed and analyzed on board of the ship. Another challenge that we had is the positioning. The drone needs to position itself very precisely relative to the ship, especially when it's landing autonomously. And there we use satellite-based navigation. You might know RTK GNSS, but we use it in a quite specific configuration where the ship sends correction data to the drone and the positioning gets very precise towards the ship. And then all the processing of the data and the control is actually done from a computer on the ship. Something that was out of scope is charging the drone, because there are already solutions on the market that you can just buy. So within this project, we prototyped the user interface and we actually controlled the drone. So we dug very deep into the technical problems that you get, and we gathered a lot of data on how this drone can be controlled, what kind of interferences that you get on a ship. And you can actually get this control software. It's on open source in GitHub. I mentioned the positioning, RTK GNSS. And there you can imagine that you have a satellite-based positioning receiver on the ship and one on the drone, and they need to communicate with each other. So we tested this in various configurations. So you have a moving base that you need to position your drone towards too. And we tested it in a lab environment and also with RC cars, and really looked deeply into this. And it looks like a very promising technology, but we need to investigate this on a ship during a longer period in operation. So what you get eventually is quite unique views from the drone's perspective. And we have a little demonstration here. So we created videos with the information that we've got. And if you can start the video. We were on board of the DFDS Petunia Seaways. And this is the interface that you can imagine that you get. You have a map with sea marks, and you can see your vessel and where the drone is at. And then you would get a touch interface where you can simply point onto the map and tell the drone to go there. And this is something that is working today. So it's not mock-up, it's actually the working interface. And then when the drone moves to its position, you can say there's a region of interest that the drone should look at. And now you will get an example of how the video will look like. If you look very closely, you can see Lena standing here and walking towards me, who is standing here. So we created several of these videos and tried to give an understanding of if you had this system on board of your ship, how would it look like to use this system and what kind of benefits do you get? And then eventually with this media that we got, created a online questionnaire. So eventually we had 3 longer videos, so this was a short excerpt, around 60 questions, and we asked 34 maritime experts. So these were captains from DFDS and Stena, these were researchers, these were also people who are involved in maritime regulation, and they got questions of the form of you get a statement and then you can agree or disagree in certain extents. And this improved fire safety was actually quite convincing to these experts. We also had a control question of, well, instead of this drone, could you not just have a person with a thermal camera who goes around? And is it the thermal camera who provides these benefits? And here the response was actually no. It's the unique view from the drone. Then we asked which of the use cases was the most convincing, and we actually got the reply that the one that we did not focus on, search and rescue, was the most convincing. So this seems to be the one that really convinces that there's a great benefit of using a drone system. Eventually what we found out is that such a drone system can be built today. The technical feasibility is very good. You can build it with open systems, so you don't need to order a drone from a country that doesn't provide you the information. How does the hardware look like? How do you communicate with everything? So you can actually build it on open standards. As I said, it's technically feasible. The legal feasibility needs to do a risk assessment, and there it would be interesting to collaborate with the ship operator and look more deeply into this. And the usefulness was also assessed quite positively. And the challenges here are to achieve a reasonable selling price. So 50,000 euro was what was kind of convincing to the expert that we asked. And then also having trust in the system. So automation is always connected to trust, and there's education to be done, and also the crew needs to get used to this technology to actually be able to trust it. Eventually everything, 4 years of work, is summarized into a SWOT analysis, and it's a little table, and I will provide a QR code so that you can get access to our full report and also to the questionnaire that the experts got, and you can also, if you want, answer the questions of the questionnaire, but it will not end up in a new report. So, but you can see how the questionnaire looked like for the experts, and you can also get access to the full report with the QR code on the left side. Thank you very much.
Thank you so much for this nice presentation. Maybe some of you have a few questions you would like to ask Marvin, or maybe you saw the drone yesterday he brought. Please feel free to ask him if you have a question.
I will be here all day, so if you have questions, you can take it later on as well.
Yes. Doesn't look like there's any questions now.
I have a question.
Sorry?
So when it comes to what other additional uses do you see with this drone in addition to the fire safety overview that you have investigated?
So one thing that is easy to do, I would say, once you have the positioning on ship and the ship is moving and everything is relative, this is quite difficult. But when your ship is docked, a lot of problems get easier. So if you want to do inspection, for example, of the ship itself, or maybe something close to the ship, this would be something that that would be quite. You already have the technology, and you just need to, add this use case, so to say. So I would say inspection would be something that is close to mind. Yeah. Thanks.
On the stage, we would like to introduce Dave Wood, talking about new technologies on fire detecting. There you go.
Thank you, Lena. Happy to be here. And thank you all also for being here. I'm going to present this new technologies for fire detection on RoRo ships. And by that, I mean the technologies that we tested on board the FTS vessel during the Lashfire project. I'm a research scientist at Rise Fire Research in Norway. I'm happy to represent the many people who made this possible. The main challenges for fire detection on RoRo ships have to do mainly with these. False alarms, basically from heavy rain and sea spray, such that you have normal expectation of false alarms when you have sea spray and bad weather in the sea from these smoke detectors, for example, or heat sensors. Reefer units with an idle engine when there are not enough outlets for them to run with the power of the ship. Cargo operations, hot work, mostly the things that can fool the detectors, not always responsive or fast. So the detectors may be faulty, they may detect the heat or smoke in a very delayed manner. Lots of maintenance work. There are so many detectors on board, and usually for 2 people to go through all the detectors, it would take 2 weeks maybe. And they are not visual, so these are the conventional ones. So Lashfire was tasked with developing some new methods and testing them and demonstrating their usefulness on board, among which were the linear heat detection system, video fire detection, thermal imaging, and flame wavelength detection. These were tested on Hollandia Seaways, which is a DFDS cargo vessel. For example, on the weather deck, we had these multi-band infrared flame detectors, shown here in the middle. That included infrared array and triple IR systems. Also thermal imaging cameras, video flame detectors, and hybrid detectors that included video and heat or thermal pile detection. So this is the open RoRo space, the uppermost open RoRo space on Hollandia Seaways, where we installed the systems. In the open RoRo space, we have the linear heat detection system. It's a fiber optic one that was tested. Along the left side of the deck, we also have a triple IR flame detection system. In the closed deck, or the main deck of Hollandia Seaways, we have this video fire detection system with certain alarm zones defined. For example, you can see the smoke zone is along the ceiling, and the flame zone is just above the height of the trucks. In order to avoid the nuisance alarm sources, such as moving vehicle lights and things like that, we talk about that a bit more. Just to give you an idea of what I mean by flame wavelength detection. So this is, for example, triple IR flame detector examples showing that they use 3 sensors to measure infrared radiation in 3 different thresholds and their ratios to distinguish flames from non-flame sources of radiation. And they are very robust. We have to the right is IR array flame detector example. Basically, this uses an array of IR sensors to locate the fire within the field of view that can be used in terms of, for example, X and Y coordinates for guiding autonomous fire suppression systems. This is an example of, for example, detection for multiple flames within the field of view of one sensor. This is an example of the fiber optic linear heat detection system that was installed on board. I have also an example cable here. It's very bendy, it's flexible. We also tested an electric one and the electric linear heat detection system at the lab You're going to read more about this in the upcoming deliverable of the closed and open RoRo spaces from the Lashware website. It's a huge document talking about the results of those tests. And the idea of this, for example, system is that it uses a cable to monitor temperature along the length of that cable, and it is much more continuous compared to conventional point detectors of heat and smoke. Thermal imaging looks at infrared radiation emitted from objects and can be used to estimate temperatures of hot regions. That can be gases, it could be surfaces, it could be anything of interest. These are tests. To the left, you can see a test that was performed in the very beginning when we installed the systems on board. The footage is from a flame wavelength detector, specifically a triple IR. It detects the flame within seconds. So to the left, we are showing it actually a flare, a makeshift flare, which is very small to see with the naked eye. To the right, you're seeing a gas burner. And for example, we are covering the upper part of the flame. That is usually tricky to detect using video fire detection that relies on certain flame flicker patterns. This is this tests done in Sweden by RISE, demonstrating how we can use IR array flame detectors to locate multiple flames and guide autonomous fire suppression systems. These are called fire monitors. Basically, with the detection system, you see and locate the fire, and then give that information to the autonomous system, which guides the water projectile towards the fire. And then we also did this in real scale, larger scale experiments of fire suppression. We also use detection systems to see how they could be used for visual fire confirmation and localization during such tests. And the fire monitors were tested for, of course, suppressing this huge fire, which was very interesting. And from different angles, trying to fight a fire and see how that can influence flame detection and fire localization. How can you see people in the area if you have a fire situation on board, for example. This is simulating a truck fire between two containers and in a weather deck environment. On the top you have some plastic pallets. At the bottom you have wood pallets, and you can see after fire suppression here you have a quick suppression of the fire, but that is also dependent on how quickly you act. So if you have a manual system, if you want to remotely control it manually, the response time is lengthened, whereas if you have an autonomous system that relies on a detection system quickly realizing where the fire is and acts immediately, that would save you a lot of costs. For example, this is also an experiment done at Rise Fire Research in Norway that shows how thermal imaging can help you identify fires that cannot be detected with any other means. There is no flame or smoke in this experiment. You can only see a fire because of the heated roof of the container. So the fire is basically inside the container, and there was no other way of detecting this other than using a thermal imaging system. So basically, to sum up, the highlights of the flame detection, flame wavelength detection, is that they can detect flames for a large area and from a long distance. They can provide fire location data. They can be incorporated with, accompanied by video cameras that can be used for visual fire confirmation and localization. They can be combined with those, and they are very suitable for weather deck environments because they are small and they are robust, and for that harsh environment with lots of elements that can destroy other detectors. Only open flames and their reflections can be detected. So from this system, you cannot expect to detect smoke or heated surfaces or concealed fires. Basically, with the thermal imaging, you have also the advantage of being able to detect hot surfaces or media such as flames and gases. It can cover a large area. It can provide live heat images, so you can see heated areas, but also, for example, people to the right. It's very difficult to notice those in the regular video footage, whereas in the thermal image, you can easily see who is in the area. And that is very valuable information to the people, operators, for example. This can be combined with ordinary cameras also. And but the The Achilles heel of this system is that they are prone to false alarms because you have, for example, exhaust mufflers that are very hot for trucks, and they are picked up as a fire source. So you either have to tune the settings in a way that increases the temperature threshold for direct detection, or you just have to accept the false alarms. And the other problem is that they are expensive. In contrast, video fire detection is actually quite economical, and it's very easy to understand the footage compared to a thermal image. This to the left, you can see an image that shows an experiment we did on board with the smoke source. From 30 meters, this smoke was detected in 30 seconds. From 72 meters, it was detected under 3 minutes. It's highly suitable for closed environments with fixed light levels. If you have it in the open atmosphere and you have changing light conditions, that can fool the system thinking that maybe there's a growing fire. So that is one of the problems. So you can use this in places where you have stable light conditions. And there is no relevant European standard for testing these. Maybe we have to work on this in the future, but there is an American standard not updated very regularly. A hybrid system would combine the heat detection with video detection. It has some of the positives of both systems, so it's more immune to false alarms than either detection technology alone, and it's cheaper than thermal imaging cameras. But it has also the downsides of for example, the thermal camera has some nuisance alarm problems, and the fact that there is no European standard for that. This is the linear heat detection system that I was talking about earlier. This system is particularly useful in open decks where you have wind effects. We, both in the lab and on board, we realized that based on the experiments, wind conditions and where you have a lot of ventilation, point detectors have difficulty detecting the fire, whereas the linear system is much more sensitive and can help you detect the fire. And this temperature information is available along the cable at every meter. This can be used, for example, to analyze the rate of rise of temperatures for alarms. And for fire location data, it's very heavy duty, as you can see later. It's, for example, this electric option is very sturdy and flexible. This also fiber optic one is very an elegant solution. It can be bent everywhere. You have the negatives relies on the transport of hot gases toward the sensor cable. So as long as the fire is, for example, hidden somewhere, it doesn't produce heat that goes towards the sensor cable, then you have no chance of detecting it. But if you have a big fire, or if you have an open fire which can direct the smoke naturally towards the system, you can easily detect it. And it could be slower to detect some flames compared to optical detectors. Optical detectors like flame wavelength detectors or thermal cameras, as soon as they see the flame, they detect it. Whereas this system has to wait for the heat to go up and then detect it along the ceiling. So the main takeaway from this presentation, let it be these. Linear systems can significantly improve fire detection in open decks where wind effects can compromise point detectors. Multi-band infrared flame detectors are the best candidates for weather deck fire detection. Video fire detection is more useful for closed decks where you have stable light conditions, and it's very economical. You can cover a long distance with just a few cameras. Infrared array flame detectors can provide the specific location of a fire or multiple fires, and that can be used to guide autonomous fire suppression systems. And lastly, thermal cameras are excellent for surveillance of hot spots, not necessarily connected to a fire alarm where they would produce a lot of false alarms. So it's just for manual visual fire confirmation and localization. They would be very useful. They can be used for surveillance of hot spots. Thank you very much for your attention. I hope this was useful to you, and I look forward to having your questions, if there are any.
Yeah, thank you, Dawood.
Thank you.
It's a really good subject. I work close with you, and there's so much knowledge about this, and we could talk for hours. So
Thank
little
you.
time.
It was a
Maybe
pleasure
some
working
of you have some questions about these fantastic cameras or the linear heat detection cameras. detection wire, cable.
Any of these systems is already certified approved as the single fire alarm system on board?
Yeah, well, onboard chips, you mean? Specifically, these are, as far as I know, they are not used very comprehensively. That's why we tested them. We wanted to give confidence and demonstrate that they are useful, but already ships use them. So some ships use them, some ships that see value in that. And hopefully this study shows that these systems are useful. And they have other applications. For example, flame wavelength detectors, they are used on oil platforms, other places. And they have rigorous testing. Linear systems, for example, they have European tests for various applications, and there is no reason they cannot be used on board. Some have even DNV class, for example, approvals. So yes, apart from the video fire detection system, which is relatively new and doesn't have a European standard, the other ones I would say they are pretty standardized. They just have to be implemented on this environment that is tricky. We see fires on board, and the detection, I think, is the first element that can help reduce the consequences of those fires, and hopefully this bridges the gap between the detection that we have and the fighting the fire that needs this early response.
Yeah, that's enough. Thank you.
Thank you, Dawood, for an excellent presentation. I have two questions for you. In your last slide, if you go back, you mentioned thermal imaging cameras and IR cameras. What are the differences between these two?
They are the same thing. Oh, sorry for the, the confusion. So thermal imaging cameras are basically infrared cameras. So there is no distinction between those, but it's just that they should not be confused with infrared flame wavelength detectors. So those look at the specific ranges of infrared radiation, whereas thermal cameras, they look at the entire spectrum of infrared usually, and they can provide visual information.
I have another question if there aren't any other ones. So I know you've been studying also quick fire confirmation and localization, because we know from the officers on board and from crew members that activation of the extinguishing system will probably not take place until you have a visual confirmation of that there is a fire, either manually by a runner who confirms yes there is a fire, or by a camera. And for the latter, could you please elaborate a little bit on secondary uses for fire confirmation and localization by these? I know that CCTV will be required for RoRo spaces in the future. A few words on that, perhaps.
Yes, if I open this can of worms, weather decks still don't have the requirement of fire detection, and now we are adding those. And as part of those, we are kind of recommending the flame wavelength detectors, but those that have built-in cameras can be used for visual fire confirmation and localization. So basically, as soon as the system sees the fire, brings up this image, and then the operator can see where the fire is. In the case of infrared array sensors, they can actually localize this flame within the field of view in the footage. So the person looking at the footage would say, oh, the flame is there. Or if it's a nuisance source, you would be able to tell, oh, this is just a guy with a reflective jacket just passing by, and this is not a fire alarm, so they can cancel it. And so such kind of the decision making is much more straightforward and saves valuable time, and it gives trust to the operators that this system is very useful, and if there is a fire alarm, they act quickly. Whereas a system that produces a lot of false alarms and you don't have visual information is very confusing and not very trustworthy information. So thermal cameras and videos, as the name suggests, these are visual and optical sensors. They can provide live images of the fire area. The operators can see what's happening there, and that's inherently useful. in terms of locating people, in terms of locating the fire, if there are any nuisance alarm sources. And we have a deliverable on that coming up soon. Look out for that on the website. Thank you. We have another question.
Yeah.
A very short one from me. Very interesting summary, first of all. And I wonder, you mentioned that many of those advanced detectors, they are coming from offshore, right, to give an extra degree of safety there. But quite often they're located remote on a mast, for example, observing a huge area because of the cost. Again, you cannot deploy many of those, for example. And here you also refer to the cases mostly from, I think, ferries or RoPax. But for example, for car carriers, right, when you have some decks where kind of you don't have height, for example, some of the types will be very challenging unless you will go with a high quantity of these expensive detectors. So I wonder if you have any ideas kind of when it comes to the pure, for example, car decks that you can actually move and you have like 2 meters height more or less, and how you can observe this area or deal with that.
Yeah, that's a very good point. The PCTCs, the pure car and truck areas, for example, that's an area that we're very interested in. So the reason that we tested this flame detector in the open RoRo space, for example, we knew that the linear system is already quite capable of detecting these fires, the ones that produce heat. But the flame detector has this limited view, as you say. We wanted to see if this would be able to detect anything, or would it have any difficulties. During the test that we did with the flare, it was perfectly, of course, capable of detecting things, but during the operational evaluations, we had, of course, no fire, so we didn't get to really challenge the system in that sense to see whether an actual fire would have been detected by the flame detector or not. But a flame wavelength detection and this video detection system, we expect them to be very useful for that kind of places. Generally speaking, the smoke or heat sensors are also very useful in closed environments, for example, like this, in the PCTCs. If you have a very closed environment, very small, chances are the fire is producing either a lot of smoke or a lot of heat. And that is detected very easily with the conventional system. But the challenge usually comes from in the open decks and the weather deck. And the weather deck, in the past, it didn't have any fire detection requirements. So now they are rolling out new regulations requiring those. And we tested these new systems just to see whether they are useful there. And the open decks, we are recommending the linear system because of the wind effect. But there's nothing stopping us from using the flame wavelength detectors, for example, in the open RoRo space. So if they see flames, they immediately trigger an alarm. But it's just
we just don't want to see flames, you know. We want to see the signs of something.
So the idea is that before you have flames, the linear system would detect it, unless you have a huge gas flame that breaks out abruptly, like a gas source. That can be picked up by the flame wavelength detectors actually in milliseconds if you need to. And they don't care if you have a 10-meter deck or a 10-centimeter deck. As soon as they see a bit of flame, they detect it. They are used in other applications for milliseconds triggering of fire suppression systems.
Thank you very much.
Yes, no problem.
Thank you very much, Stuart.
Thank you.
Let's get ready to the next presenter. While he get ready, can tell you that I visited Hollandia Seaways and last week, and I saw that all the equipment is really nice. There's no rust on it, so it done a good job so far. Let me just get. Please, Vasudev, come to the stage and let us know everything about electric connection in reefers.
Absolutely.
There you go.
Thank you so much. Hello, everyone. Good morning. Really happy to be here and continue sharing some results from the project Lashfire, which we have been speaking about for a while now. But like the rest of the project, the point of this part has been also to prevent ignition, but the focus is on electrical connections. And the reason for this stems from a little bit of literature study, which reveals that about 2/3 of all fires in RoRo spaces are electrically caused, and a significant number of these are because of faulty reefer units. And that is not very nice. And also it is not an easy problem to solve because there are so many kinds of reefer units from so many different manufacturers. Some are old, some are new, some are maintained well, some are not. And it's usually not up to the ship owner to have a say in any of these. And they have to accept the reefer unit as it is, as a cargo. And from their perspective, once it's on board and it's connected, it's nothing but a black box on which they have no control over. So one of the aims of this part of the project was to develop better solutions and guidelines about how to deal with such reefer units, how to make it a safer environment, electrically speaking, and to come up with a more hardware-based technical solution which can do a lot of these monitoring, which partially is done manually today, and some of it is not done at all. Another part is also that there has been a growing need for transporting EVs, and by transporting EVs I mean on a passenger ship, so therefore they are not new EVs that are being transported, but rather electric vehicles that are owned by people. And because they are being transported, there is also a need for them to be charged while on board, and this is a service that many ship operators are happily willing to provide, provided the infrastructure is pretty safe, because it's pretty profitable and lucrative, I think. But since the whole field is new and there is also a lot of stigma around electric vehicles and battery fires, and there's also a lot of research going on about how the battery fires are different, how they have to be fought differently. That is also part of this, where we consider the electric vehicles also as black boxes, which are just plugged into the charging unit, which is on board the vessel, and then to develop a solution that can monitor the state of health of, let's say, these electric vehicles. You do not have to read those. I have done that on your behalf, which is why it is pretty small. But this is just to highlight my point that there have been so many cases of these fires, and especially these. They are not fires exactly, but they are near miss cases which have been identified by sheer luck. And that is something we shouldn't rely on in this industry or in these kind of ships. Definitely not. So in all of these cases, there has been some crew member or some passenger who has identified that, oh, something smells wrong, and they look and it's a spark which is about to smoke up or cause a fire, and then the particular unit has been disconnected, or in some cases, there has been a fault, and then the runner has to go down and then check all of these reefer units to see which one is the problematic one. So these are some of those potential risks that could have been turned out really bad, but was not because of luck. And this is what we want to avoid in the future, not being lucky, but not relying on luck, rather. So there are two lines of solution that we have come up with. One is a more qualitative approach about the operational aspects of how things are handled on board. Some of the protocols that are on board today, it is very simple to be looked over, to say the least. For example, in the image on the left, it is a standard reefer unit which is on board, which is connected by an electrical cable that you see here. But if you notice a bit carefully, the spare length of the cable goes underneath the reefer on the left. And if this is not fixed, and when you're unloading the cargo, the reefer unit on the left will drive over the cable, which is on the floor. And there will be internal shorts because of insulation faults within the cable, and that is not good. And these are the kind of electrical faults that slowly creep up and result in something which is pretty bad, which ends up in pretty bad. So this list of solutions, they focus on developing standard operating procedures, which are pretty easy to use, but also pretty easy to look over, like I mentioned. They also speak about certain guidelines. For example, who the connections are to be made by. It is only the crew members who have to verify the sockets because, for instance, all of these are in pretty salty environments, and they have deposits which cause a lot of sparking, localized heating, and over time that also causes insulation faults and fires, for instance. So these are some of the operational aspects that we have worked with. And I will, it's a bit too much to talk about all of them in the 10 minutes that I have been given. So I will share a link like everybody else did, and there is a document where you can go through all of these recommendations that we have. But for me, my more favored solution is the technical one, where we have some hardware that is implemented which does a lot of this monitoring of these reefer units. So before I go on to explain what all of this mess is about, I will quickly just tell you what the solution does and how it works, rather. So the idea is that, like I said, all of these reefer units and electric vehicles, they are all considered black boxes, and we pretend that we don't know what is happening inside of them. What this solution does is basically it monitors from the outside or externally, it monitors all of the crucial electrical parameters between the reefer and the electrical grid of the ship. And by this, what happens is that we get real-time information about the insulation levels in all of these. If there is an insulation fault, this solution allows us to pinpoint the exact reefer out of say 100 reefers. This solution allows us to pinpoint the exact reefer unit which has the insulation fault, for example. And all other parameters like the power consumed by each of these reefer units, the individual phase voltages, the currents in each of these phases, the phase differences, example, etc., all are monitored real time. And there is a central computing unit which basically collects all of these data from different sensors which are connected to different reefer units. And it runs an algorithm which can basically raise a flag and an alarm that says, okay, reefer number this has a fault of this sort, and the fault is this bad. And this system also gives the possibility to disconnect any individual load, and by load I mean either an electric vehicle or a reefer unit which is on deck, to be remotely disconnected, which so far is not the case in any of the vessels. So as of now, somebody, if they notice a fault of some sort, which is not in this detail at least, they have to go down to the deck, run around, find the faulty unit by making measurements on each of them, and then manually disconnect them. But this solves all of that problem, and you can instantaneously on a screen know what problem is in which reefer unit, and you can make a judgment of if you have to disconnect that unit, and you can do it from the bridge, for example. A simplified version of the solution of this cabinet unit is as follows. And to very briefly explain, I will take a bottom-up approach. So these that you see here are the sockets where the physical connection to the reefer units on deck is made. These are manual breakers, and these already exist on the deck. There is nothing new with these. What we do, or what we recommend, is to have this setup, which is installed either on new builds or on existing ships. One of the advantages of the solution is that it can be implemented on an existing ship just as easily as it would be on a new build. So we have energy meters, which are basically transducers that are in series with each of these connections, and they monitor parameters like the power consumed, the voltages, the phase differences, etc. And then we have these breakers, which are remotely operated by the onboard computer, like a central computing unit. And then we have this, which is basically an insulation monitoring device and a fault locator in case there is a fault. They are fed information by these tiny current transformers that are on every line. And yes, so it's as simple as this, but it works very well. And we have been testing this on a demonstrator on Stena Scandinavica. And we have some very interesting results where we can very quickly catch even very tiny faults in all of these reefer units. One of the things that also, like Dawood was mentioning, was about false positives or flags that are not important, that can be ignored. But to refine that, I think we need some more data and a lot more measuring time on probably more number of sockets and more number of ships. So hopefully that happens in the future. Yes, I covered a little bit of that. One possible outcome of this project could be to eliminate completely the need for an insulation measurement, which is currently, as of now, a standard. But it looks like it will be possible if you just measure the current. But it's an interesting thing to think about from an engineering perspective, but not so much from a regulatory perspective, I believe. And to quickly sum it up, some of the advantages, like I have mentioned through the talk. First of all, we're reducing the number of incidents, both electrical faults and the ones that lead to the fire, which has been the ultimate goal of this project. Secondly, but definitely not any less important, is safety to people, because in compact areas and smoky environments, it's not nice to go through those tiny gaps within reefers to find faults. It could also be bad with fires and not just smoke. And of course, also with that as a byproduct is lesser loss to cargo, because if you prevent faults, then you have safer cargo. Yes, this is a QR code, which basically leads you to those two reports, which detail all of these operational and the technical details of the solutions. And you will also find a lot more information there about the cost effectiveness of these solutions and the environmental assessment, etc. But with that, I thank you all and welcome any questions.
Thank you so much. Do we have any questions from the audience? Maybe friends?
It's just a comment. I know that you're planning on a future project. You said you want to have this equipment on more ships to be able to evaluate the data, etc. So I know you're planning on a future project. So it's more of a comment that if you want to try the system on your ship, talk to Vasudev, because we're planning a future project on this. Really, like you mentioned at the start, 2/3 of all the fires are caused by electrical faults, and 1/3 are caused by reefers. So it's a huge potential to reduce the number of fires, I believe. So I think it's a great potential in this.
Yep. Absolutely. So I am also here all of today, and I would love to collaborate or talk more about this problem that you might have faced, and maybe do some experiments on your ships as well. Thank you.
The next one on the scene is myself. My name is Lena Brandt. I work for DFDS as an officer. I sail as a relieving officer on Pearl and Crown Seaways. Also, I work as project manager for the Las Fire project, and we have been working across all the work packages, letting tests be done on board our vessels and taking part in a lot of drills. Today I want to share with you how we use the information that we have gained the last 4 years in less fire, and also the information we got from IMSA guidelines. Drencher system is our main fixed firefighting system on board our RoRo vessels. They are supplied with this, and we encourage our crew member to use it because the tests that have been done have shown it can suppress it. It reduces also the contents of the hydrogen fluoride gas, the gas attached to the water droplets, and you can actually reduce it by running the drencher system and like washing it out a little bit. We want fast activation, and it can be done remotely or also manually. We only have very few vessels. Our new RoPax vessel can do it remotely, but the biggest amount of our vessel will be done manually. Oh, there we go. I have borrowed some photos, or Magnus Arvidsson from RISE, Work Package 10, he have shared these photos with me. He have done a lot of tests on sprinkler systems. These 3 photos is an electric vehicle that he have provoked a fire in. What we want to show you with these photos is that when there is a fire in the electric car, and we uses the drencher system, it is able to suppress the fire. But what happens when you are not using the drencher system and it is an electric car? The car will reignite again, and this is what we see here. So his evidence is that the water can suppress the fire if it's an electric car, which you cannot put out. Back to our vessels again. What we want our crew members on board to be very good at is fast activation when it's done manually. So we want them to be trained at fire drills. Here we have the chief officer doing a training where he's showing them, here we have the sprinkler system. What is important for us is to keep our scuppers clean, the deck clean. We can have guests that they have an ice cream and their kids will throw it on the deck. And if it's lying there, it will clog up. And if we run the drencher system, if we have to run it, it might develop on the deck and we will have a bad stability that can lead to another great disaster. So fast activation, we try to train them, not only one person, but the whole crew. Should be the deckman, it should be the engineer, the officer who know how to activate it. Clear instructions should be available also. Like Magnus Arvidsson said, do not stop the drencher system before you have your manual firefighting ready. It's quite important. So when I'm on board the vessel and talking with the crew and demonstrating equipment, they will say to me, but Lena, you just said to us you have the drencher system. It's the best system, run the system. And now you want to send in manual firefighting. Why and when should we do that? Why? You could have a person lying on the car deck if there's a fire. We want to save our crew members. It could be a stowaway. It could be a passenger that for some reason found access down there, even though it's locked. When should we do it? Should we send in our crew members when we have a lot of fire on the car deck? Of course not, because we want our drencher system to suppress it. So in the early stage, in the early detection, there's a chance to come in, put in boundary cooling, fire blankets, or withdraw persons that might be stuck in there. And in the latter part, where the drencher system have done the work, there's no big flames, we are able to get firefighters in and maybe cover an area not close to where the fire is, but in a sensitive area. We can put up our fire blankets and cover that area so the fire will not spread. We have taken parts in training Academy in Spain. It's a part of the Las Fallas Centro Urbanos in Gijón. We have had crew members down there taking part. Everything we learned and trained with boundary cooling, the fire blankets, we have implemented in the FDS. This is from on board our vessels where we are training with the crew. You cannot just send out all this equipment and think, oh, piece of cake, they will do it. Of course they're clever, I know that, but they also need training and they need advice how to use it and good ideas. These persons, our crew members on board, they have so much knowledge and they like to share with us. But sometimes it's stuck on one ship. We want to implement it to all the other vessels. Also here we see the undressing procedure. It's important to teach our crew members to undress if the fire suit have been polluted with the dangerous toxic HF gas. Also a fog nail we have upgraded on board. It's to penetrate, for instance, a trailer. We encourage the crew to train with that, so they have a feeling how hard it is to pierce through a metal plate. This is the packet we have upgraded the FGS vessels with. It's from the information that we have gained from the training, from the Las Fire, also from the ELBAS project we have taken part in. We have put on board each on the entire fleet, all our vessels, 4 fire blanket, the FLIR camera, boundary cooling units, portable. I don't know if you visited me yesterday, I had the red lizard over there. It's a boundary cooling device you put up in between cars or on the cars and it will cool. We have a similar one, we call it grab and go. The idea is the same, to cool. Also the fog nail, where you pierce through the metal plate, and we have upgraded with new fire suits. At the fire school, we had a different way of approaching problems. This is from a trip where I brought a crew down. It was a very special training because the ship was sailing. The fire school have a simulator so we can equip it with the officer, the captain and the chief officer were sailing the ship in Dover. They were taking care of the traffic, the authorities. I even pretended to be Michael Stie, the DP from our company, calling, asking, I heard you have a fire on board, and I was told by the captain, you can wait, you are not important now. The important part was to put out the fire at the car deck and make sure that the crew members were okay. Down at our place where our fire leaders were fighting the fire, he had the chance to play around with CARF, compressed air foam, sprinkler system, CO2, and of course manual firefighting. We put in magnesium, class 4, just to spice it up a little bit and see how will you act when you have a trailer full of magnesium where you cannot add water. To get it even more spicy, we said, oh, I'm sorry, the communication is not working between the bridge and the fire leader on the deck, so we need a runner. The communication and the lack of communication had a great impact on this drill. And of course, the runner thought it was quite irritating, but it was so interesting to see what is not coming up to the captain, what is the communication that are left. It have a big change in the drill that the fire leader cannot talk with the captain. Very interesting. Afterwards, we asked them to use condition cards to pin out and map what are the problems, what did you face, and again, interesting to see that the crew on fighting the fire saw different things compared to the captain on the bridge, who saw the pressure from the authorities calling him, the lack of communication, where the fire leader was looking into, what should I use? I have different things. Should I send in the people here? Should I stop the ventilation now? All these things. Also, we have rolled up everything we have learned, all the information we have in an e-learning, basic knowledge to our crew member. It's been sent out. It's about 30 minutes knowledge, basic knowledge about what is causing the fire, what can we do, what should we be aware of, is it dangerous to us, and how can we protect ourselves. One of the questions, there are 5 questions, quiz questions in the end, and one could be, what is an additional risk when dealing with fires in alternative fuel cars? And of course they have to get them right. If you're wondering now what could it be, I will tell you it's not the battery is likely to explode. It is the hydrogen fluoride gas that we are dealing with that will be toxic to your skin if you touch it. And it's also that the drivetrain can engage without notice. So when you have an electric car on fire, it can actually start moving. That was a short peek of what we have done in DFDS and how we have used the LBAS project and what we have taken part in and how we are using it on board to make our crew members strong and ready for what they're facing out there. Yeah. Any questions? Yeah.
Hi, I'm Mark from Arepa. This might be a more commercial question, I hope you don't mind. But you obviously put up a platform to explore and develop a lot of new ways to detect fires. And some of that is motivated obviously by EVs and battery fires. This is not only RoRo, this is in a lot of cases, of course.
Yeah.
But at DFDS, how does these new battery or other fire risks reflects your amount of installations, to discover the fires? Do you add more? Does it affect that you have to put in more systems in fire detections, or
we have the best system. We have the sprinkler system on board, and we have also our cameras, of course, on the car deck. And with our upgraded equipment on board, we feel that we are dressed very well. Looking into the future, it would be lovely to have some infrared cameras on the car deck for early detection. So that will be the future for us.
Okay, so yeah, you do have more and more detection systems. Of course, it comes with a cost that was pointing out always. But infrared, or what did you say, infrared or thermal?
Thermal cameras. What we saw Daewoo were presenting today would be on our wish list for our vessels to have. Maybe new buildings in the future, yes.
All right, thank you very much.
You're welcome.
Thank you very much. Yes, Lena, you mentioned the piercing tool, the fog nail.
Yeah.
I thought maybe you could just elaborate what it should be used for and what it should not be used for.
Yes, of course. Originally, it's made for the container business, to pierce through the containers. But we think that we sail around with a lot of trailers and trucks as well. So if it can be used for this, if we can save one fire using this equipment, it's worth it. What it should not be used for, and it's very important, which we also tell our crew member, is not to pierce through an electric car. Because if there is some wiring somewhere and they hit the wiring, we don't know what will happen. So we say, if it's a car, please pierce through the windows, not through the metal on the car. But for the trailers and trucks, it's metal and can be used there. So you pierce through and then you add the water. And I will tell you that the water coming out is so soft and nice. The droplets are so fine, so it's it's amazing how nice it is, this water. So it have a very cooling effect inside, where it's pierced through. Yeah.
I have a general question. How many hours do you need to suppress a fire of an electric vehicle?
It's all up to how long it's going on. We know that the state of charge, how much the battery have been charged, the longer the fire will go on. But we will say just keep on suppressing with water until you maybe get professional firefighters on board. They might have different tools. Something we also have tested, it could be something they can pierce through to the battery and inject straight to the battery. We have not implemented that in DFDS. It's for the professional firefighters.
Thank you.
You're welcome. So next in the line is Alexander Kleiman from DBI.
Thank you,
There you
Lena.
go,
Thank you very
Alexander.
much. Thank you. And good day, everyone, and thank you for coming, and even more so, thank you for staying. I have the honor of being the final presentation of today, and I'm the only one of our good speakers today that are not directly associated with the Last Fire project, but I come from the Danish Fire Research Institute, and will tell about the research that and our work that Lena mentioned, which was inspired by Last Fire, and really is a spin-off project from Last Fire, looking at EV fires on board ferries. Given the limited time, I can only touch the surface, but and the title of my talk today is how to handle EV fires at sea and once in port. Couple of important points to be aware of are, of course, the reason we've looked into this is the ever-increasing number of EVs and alternative power vehicles that are being transported aboard our ferries. And there was really a need driven by industry, actually, to investigate and to understand the properties of these vehicles and how they burn, and if they introduce new challenges on board ships. We've actually, through our research, gone a little bit away from focusing exclusively on EVs. EVs are one modern vehicle, but in fact, through a lot of our tests, we find that the vehicles of today, as we call them modern vehicles, pose new risks and challenges to firefighting that the vehicles of even just 10, 15 years ago don't, including release of hydrogen, HF gases, hydrogen fluoride gases, and so forth, just given all the plastic and electronics and airbags and alike. So one thing is the battery issue and challenge, but it's the actual car fire in general. And basically our conclusion or recommendation is to really, for all ship companies, to update their fire safety strategies, to look at the current practices, obviously the regulations and the compliance, but far beyond that, to look at your policies and procedures and see if they adequately address these risks. And certainly DFDS, as Lena mentioned, is one of on the forefront of that, and some of the other partners as well. But also a change in philosophy in fighting fires. Obviously, the goal is to ultimately have it extinguished. But perhaps given the complexity of these fires, it's also very important to emphasize the containment, as you mentioned, and the limitation of spread, because some of these fires can develop in ways that are very difficult for the crew to handle. And we must always remember the crews are not professional firemen, will never be, but they're expected and have to deal with this immediate situation. But we would encourage an open dialogue with your shoreside authorities, the professionals, to develop strategies together. And lastly, I'll speak briefly about realistic fire response training and increased, as I said before, increased coordination with shoreside authorities. This is our LBAS report that was issued earlier this year. There's a QR code where you can link on that and download the report. Some of the things I'll be discussing today are the findings and recommendations from that, but I would strongly encourage getting the report. And I just also want to thank some of the Last Fire partners and others, the 4 ferry companies involved that were critical in getting this project performed. As I said earlier, there's an ever-increasing need to focus on practical solutions. And really, to date, knock on wood, the only documented and let's say incident, a formal incident, occurrence of an EV fire, at least on a Danish flag vessel, was back in November of 2010 with a homemade electrical vehicle. But as Lena said, one of the best resources to learn is to speak with crew members and understand what happened. And with the FDS involved in LBAS, we had the opportunity to actually meet some of the people that were on board in those at that time and learn from their experience. The areas that LBAS investigated, besides the technical aspects that we've heard a lot about this morning, we've also looked at the human element, how the crew responds, the knowledge, the setup, and of course evaluated various technical solutions. We performed fire simulations of the ferries involved on the car deck, and focused in the end on the realism of training, drills, and these larger scale exercises. And as I said before, it's important for ship owners and operators to look at your current procedures. Do they adequately address some of these risks? Is your training as realistic as it can be? And have all the new hazards and risks been identified and incorporated in your fire safety strategies? And lastly, strongly encourage the performance of joint drills and exercises with the shore-based authorities, because they will play a critical part in addressing these things. Traditionally, we've all seen ship fire plans are available on gangways and so forth, but we feel that maybe that isn't really enough. It's important to invite them on board and get them involved. I have a short video. Unfortunately, I understand there's no audio here, so I'll just try to narrate it briefly, but otherwise you can watch the full version. So please, on the website, so please just start it. But this basically just shows the setup as part of the LBAS project. We had originally wanted to actually perform these tests on a real ferry. That turned to be too expensive and too many challenges there. So instead we made a mock-up of a car deck with, as I'm describing here, where we ran a number of experiments with an EV in the center and with fixed installation, sprinkler systems and rock wool insulation and so forth, and tested out different equipment, but also had a chance to have crew members try it out on their own. Yeah, it's a few minutes. You can see it on the website. We can go on. But again, the focus on realistic drills and training and these joint exercises is certainly a lesson or a conclusion we found with success through the LBAS. It wasn't just testing the technology, but also giving a realistic training environment for ship's crew and others to actually try it out on your own in a safe environment, in a protected environment, but to feel the heat and the challenges in the limited space on board. And again, just to emphasize, we're looking very much into these joint exercises because shipping companies and the maritime authorities have responsibility for maritime, but the land-based emergency services are different from country to country, and it's really important to start that dialogue. We have the onboard training, which is really good to test the equipment, the response times, and so forth with smoke machines. But in reality, a realistic condition may be different with a full car deck, and that's why having these training facilities are really quite valuable, we believe, and having it with real fire. And again, joint exercises is also important because you identify things you may ahead of time before an actual incident should occur. Can develop joint strategies of the shoreside of emergency services utilizing the equipment available on the ship and so forth. And it can involve all sorts of both, the fire department, but also port services, search and rescue services, or other services available in the port. And also just to give them an opportunity to come on board and visit the vessel, and a lot of these professional firemen have never been on board a ship, and to understand the limitations, both the tools that they have available, but also the limitations to the ship crew. So basically, in summary, I had to be very quick, but in the entire project, we basically the main point is that there is no one-size-fits-all solution. There isn't one magic piece of equipment that we would recommend that everyone buy. Lena mentioned that DFDS has a whole kit of different tools available depending on what type of a situation you may encounter. And every ship is unique. Every shipping company has a unique makeup of crew, and the resources available ashore differ as well. So it really requires an individual risk assessment or an individual evaluation of the operation to make the right strategy. And again, we can only strongly encourage enhanced fire safety training with live fire situations that go above and beyond the minimum requirements in STCW. And lastly, as I said before, the increased collaboration with the shoreside authorities. So that was it. That was very brief, but thank you for your attention. If you have any questions, I'll be available, or please reach out to me on the information on the screen. Thank you.
Thank you
Are
so
there any
much,
questions?
Alexander. I just realized when you were talking, we actually have two of the firefighters sitting here today.
Very good.
That Mikael and Søren
Yes,
that
of
took
course.
part in one of our training sessions, and it was a tough day. They looked tired in the end of the day. Any questions for Alexander? So Francis.
That's good.
Yeah.
I was
So,
thank you.
yes, in your opinion, so we heard from Lena all the new tools that they bring on board to address EV fire safety, and you mentioned how important the training and drills are, etc. In your opinion, whose responsibility should it be to develop this kind of training that should be supplied to the crew members? Should it be the operators themselves? Should it be the maritime training centers who offer basic training and advanced firefighting? Or should it be, I don't know, the regulators who should say how it should be done? Like, it seems like everyone is asking for it, but no one is really knowing how it's supposed to be done. What's your opinion?
Thank you, Franz. Very good question. Of course, coming from a Fire Safety Research Institute as yourself, I believe that we play a critical role together with the operators in the first instance, because in the end of the day, it's your ships that have to be protected. It's our research that helps come with solutions and can develop these things, of course, together with the training academies. They are very good. They have the facilities for these types of training courses. However, they typically offer just the regulatory required training courses. And I think it requires a cooperation amongst all the parties. Regulations need to be there as well, but as we all know, and in our experience with IMO regulations, they're very slow in coming, and we can't wait. The technology and the risks develop much quicker than the regulations can keep up. They can always follow. Once we have good solutions, then maybe the regulations can reflect the solutions that we identify. Any other questions? Lunch is served very soon. But well, thank you for the opportunity to come, and
Thank
I
you
don't know
very
if you have some
much.
final words.
Always lovely to work with you.
Yes,
Yeah.
same. Thank you.
Final questions for any of the things we've been talking on today? Any of the subjects? If not, we are still here. Reach out to us, get hold of us. Maybe some of you scanned our codes. Write to us. We're happy to talk with you and discuss things or help out.
So then, I will take the floor again, and before we say thank you for today, we would like your assistance answering a couple more questions. So pull up your phones or computers or whatever. Those of you who are streaming, you can answer as well. And you can go to the same Menti page as we used before, same code, 3192 1637. 3192 1637. And the next question is, you will show on your phone, but it is what RoRo ship fire safety risks should we focus on going forward? We'll change the screen here momentarily once you have put down the code. So 3192 1637. You can switch now. And we'll see what your answers are. So it's actually a multiple answer question. Let's see here. You have to, I think, go back. Maybe there has been some mistake. Okay, some technical difficulties here. Jag måste gå tillbaka en slide. Let's see. There we go. Okay. There, yeah. So what RoRo ship fire safety challenges should the future research focus on? You can't see the answers here. You can see it on your phone. The alternatives are safer reefer connections. We heard Vasudev talk about that. Fire detection, presented by Dawood. Fire training courses connected to STCW. We just talked about that as well. Fire safety with reduced manning. We know that automation is in the future. Perhaps not fully automated ships with passengers quite yet, RoRo ships, but at least with reduced manning. Collaboration with external rescue actors. In case of a big fire, you need to collaborate amongst many different stakeholders in order to make an effective action towards the fire. Electric vehicle fire hazard. I don't think that requires any further introduction. We hear a lot about it in the media. And finally, other. You can put that there and you can contact us afterwards. This also helps us regarding where to focus our future efforts in our research. So it's nice to see that we at least kind of pinpointed some of your interests here. Safer reefer connections, we talked about that, the huge potential to reduce those fires. Fire training courses seems to have a lot of interest as well as electric vehicle fire hazards and collaboration amongst many different stakeholders. We have the fire and rescue services, we have the sea rescue services, we have the ships, of course, and many different stakeholders need to collaborate in case of a big fire. We'll move on to the next one. Finally, in 2 years, we'll meet here again at Safety Meet at DSM. So the final question is, let's see, your suggested topics for DSM Safety Meet 2025. You don't have to answer right now. We'll keep this one open for another 15-30 minutes. So if you want to grab your lunch and talk about it and think about it, you can answer in your phone momentarily. But we are eager to hear about what you want to know more about and hear more about at our next DSM. And for those of you who are streaming, you can also answer right now. So thanks a lot for your attention, and I'll hand back the mic to Lena.
Yes, thank you. Let's hope in 2025 I'm better with this, because it doesn't seem to work very well for me. Please go on our website. In Last Fire website, you will see that there we have done some movies, and you are able to look at them. We have also done some things that are available here when you are leaving. You'll find it on the internet as well. But a lot of nice video for manual firefighting, the test we have done. So look into it. Again, I thank you for all our sponsors who taking part in the Last Fire project as well. But this is the end of today. Lunch is waiting for you. You've been very patient with us, and it's been lovely to hear all your questions. And please feel free to contact us again. Yeah.